Math 70, Section 6.1, Greatest Common Factor and Factoring by Grouping. The information you're going to be learning in this chapter is extremely important because you're going to be using it throughout the rest of this class and into Math 1000 and so forth. So factoring involves every math class that you take, even if you're in pre-calc, calc. So let's talk about what a factor is. When you take a number, let's say the number 12, and if I were to break this up, 12 is 2 times 2 times 3. 2, 2, and 3 are called factors of 12. So products are factors. Okay, so if you look, here are some examples. 5 times 3 is 15. 5 and 3 are factors of 15. 5x plus 2y, this is what we're going to be doing. 5 times y plus 5. The 5 and the y plus 5 are factors of 5y plus 25. So numbers or polynomials that are used to multiply are called factors. Okay, so when you are factoring, to factor a polynomial, it means to write the polynomial as a product of two or more polynomials. So the first thing we're going to do is talk about the greatest common factor. So if I give you two numbers, so in this case 12 and 18, okay, you're going to make a factor, however you want to do it, but I like to make factor trees. So I'm going to take the number 12 and the number 18, and I'm going to break them into their prime factors. So 12 is 2 times 6. 2 is prime, but 6 is composite. 6 is 2 times 3. Okay, so 12 consists of 2 times 2 times 3. 18 is 2 times 9, and 9 is 3 times 3. So 18 is 2, 3, 3. So the greatest common factor of 12 and 18 is, we're going to circle the ones that are common to both, and we have a 2 and a 3 common, so 2 times 3 is 6. So 6 is your greatest common factor. So that's the number that will go into both of those numbers. So what if there's 3 numbers? So we've got 24, we've got 40, and we've got 72. If you made a little factor tree on 24, 2 times 12 is 24, and 2 times 6, and 2 times 3. So 24 is 2, 2, 2, 3. 80 is 8. 8 is 3 2s, and 8 times 5 is 40. And 72 is 8 times 9. There we go. 8 times 9 is 72. So what's common to all three? We've got a 2, another 2, another 2, and that is it. So 2 times 2 times 2 is 8. So 8 is your greatest common factor. Okay. What happens when we have variables involved? Oh, you're just going to do it the same way. Treat each variable like it's you have in this case 8y to the 4th. 8y to the 4th is 2 times 2 times 2, and then you have 4 y's. So each y is a product, and then 12y squared is 2 times 2, that's 4, times 3 is 12, and then we have 2 y's. So what's common is we have 2 times 2 is 4, and then y times y is y squared. So 4y squared is your G greatest common factor. Okay. Next problem, example 4. We're going to mix up, we're going to do, this is just the same stuff, but we're going to use 3 terms. So 3x to the 3rd is 3xxx. 9x squared is 3 times x, and 21x is 3 times 7 times x. So what's common here? Common to all three is just a 3 and an x. Okay, and then for b here, 10 x to the 5th, y to the 4th is 2 times 5, and then we've got 5 x's, and you don't have to do all, you can see the shortcut. We have 4 y's. 15 is 3 times 5, 2 x's, 3 y's, and I like to line them up. And 25 is 5 times 5, 3 x's, and 5 y's. So what's common is a 5. We have 2 x's, and it looks like 3 y's common. So the greatest common factor is 5x squared y to the 3rd. Okay? So we also have binomials that can be factored. We can pull out some factors. So if you look at this, this says for a, we've got a, one of the factors is 3 and then x minus 1. And for the second one, we have an 8 and an x minus 1. So what's common to both of these is just this x minus 1. So x minus 1 is common. Now, if this were a 2, we could pull a 2 out of both of these, but 3 is prime and there's no 3 that can be factored out of 8. So just x minus 1. Now for this one, we have a 2 and a 4. So a 2 is definitely a GCF. And then we have a z plus 5 here, and we have 2 of them here. So we're going to say a z plus 5 is also common. Okay. Example number 6. Now we're going to use the GCF to start factoring out the greatest common factor in polynomials. So here's your first example. We've got 2x minus 10. So if you look at 2x, 2x is 2 times x. And 10 is, I should write 2x, and 10 is 2 times 5. So we are going to pull out the GCF, which is 2. There's a 2 in each of these. So you take the 2 out, that's your GCF. What's not common is what would go in the parentheses. So in the first term, x would go next. Whatever this sign is goes next, and then a 5. So we have the GCF out, and then we have x minus 5. Now you could check this by using the distributive property. 2x minus 10 should get you back to that polynomial. Okay, let's try another one. Example 7, we've got 9z to the 3rd plus 36z squared. So 9 is 3 times 3, and then z, and 36 is 2, 2, 3, 3, z. Okay, so 6 times 6 is 36, so I have 6 times 6 and then 2 z's. So what's common, we've got 2 3's, and 2 3's is really 9, and we have 2 z's. So what's common, the GCF would be 9z squared, that comes out. What's not common in the first term is a z, and then bring down the plus sign. And what's not common in the second term is 4. 2 times 2, you have to bring it back in and multiply. So this is factored by GCF. Then we have example 8, factoring out the greatest common factor, same process. Now you can go quicker by just looking at these 3 terms and saying what's the biggest number that goes into 6, 8, and 18, and then how many common A's are there, how many common B's. You can do it that way. But to make sure everyone understands this, 6 is 2 times 3, A, B, B. Then 8 is 2, 2, 2, A, B, B, B. and 18 is 2 times 9, and then A, B, 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 B. So that's each of these terms broken down. So what's common is definitely a 2, only one 2, because these two don't have any more 2s. Not a 3, because there's not a 3 here, but there's 2 here, 1 here, but there's none here. Then we have 1A common, that's the most, and we have, looks like 2 B's. 2 B's, 2 B's common. I'm circling them like that. So the GCF would be 2AB squared. 2AB squared. What's not common in the first term is 3A. Then bring down that sign, minus. What's not common in the second term is 4B. And then bring down the plus sign. And what's not common in the third term is 9A squared, 9A squared B squared. Now in the parentheses here, there should be nothing common. There is nothing. And if you wanted to, you could distribute this GCF by multiplying, and you should get the original problem. Okay. Number 9 is asking you to factor out, whenever a polynomial starts with a negative, you always want to pull that negative 1. But for this one, I'm going to pull out a negative 7A. That's the GCF. So if you take out the negative 7 and the A, you're left with A squared. And now if you divide this by negative 7, you get negative 2. Now double check. I know this is a plus sign and this is a minus, but we took out a negative 7, so we divided this by negative 7. That's why this became a negative. If you're not sure, distribute. So negative 7A times A squared is negative 7A cubed, and negative 7A times negative 2 is positive 14A. It needs to make sense. So that's now completely factored. And we've got this one right here is stretched out. This is, I'm sorry, hang on one second. 9, yep, that's 10. All right, so now what you're going to see here, you got to look carefully. These are two separate terms. They're separated by a plus sign. You should see these two terms are common. So these are factors. So x minus 2 gets pulled out. And so if you take it out of these two, what's left is 5x here. Bring down the plus sign. And I took this out. You have a 3 left. So these two are that. And then 5x plus 3 is what remains. Okay, and that's, now factoring by grouping is what we kind of just did on example 10. But now you're going to be asked, you're going to see 4 terms. You have 3x minus 3y plus ax minus ay. Break these up into 2. So take the first 2 terms. You should see a 3 common to both of these. So if I pull a 3 out, if I yank this 3 here, you're left with x minus y. So I factored a 3 out, and I'm left with x minus y. Then bring down the sign here. These two you're going to pull out an a, and you're left with x minus y. So this a and this a were pulled out. Now you should see x minus y here. So you take that out, x minus y. Those are gone, and you're left with 3 plus a. And that is called factoring by grouping. You'll see 4 terms where you want to take 2 at a time and GCF something. Okay. 12 is another factoring by grouping. So we are going to factor this by grouping. You should see 4 terms. So we've got 5x, let me copy it, 5x minus 5y minus 4bx plus 4by. So in the first two terms, I see a 5 I can take out. You're left with x minus y. The next, you're going to take out a negative 4b. Negative 4b gets taken out, and you're left with x minus y. Now these two will match, x minus y. And then you're left with 5 minus 4b. Okay? And example 13. 13 says we have 3x cubed. 3x cubed plus 12x squared minus 6x minus 24. So the first term, I see a 3x squared. I'm going to take that out, and you're left with x plus 4. Here, take out a negative 6, and you're going to end up with x plus 4. X plus 4 is common here and here. And then you're left with 3x squared minus 6. And that concludes section 6.1.